Welcome back, everybody. In this video, we're gonna first discuss what a sequence is, and then it's because often in Python or in any programming language, we iterate upon a sequence. So we're gonna first go have a look at what a sequence is, and then we're gonna delve into uh, more about using for loops later on. Okay, so let's start. All right, so let's take a look of real world analog of sequence. Okay, so basically we days in a week is a sequence. Okay, so sequence of days and numbers in a week or a month or a year, it's a sequence of integers. Okay. Students in a class is a sequence of mathematical progressions like geometric or arithmetic progressions. Those are also sequences. Okay. So why do we group objects into sequence in real life? It's basically to identify them as a unit, right? So uniquely identify, and then basically we can call them collectively. Okay. We can apply a common stack. For example, if it is mail processing, we apply labels. We can arrange, order, or sort objects, things, letters, words, numbers. Okay. And not only that, we can refer things inside via an index. We can consider a certain order and give it an index, and then we can basically refer using that index. For example, if in a line, we can call the fifth person in a line with that number. So in programming world also, we use the sequence to serve the same purpose. Not simply because we solve real world problem in programming. So in collectively in Python, we call them sequences. Okay. Strings, list, tuples, ranges in binary data types. Basically, those are sequence in Python. Okay. So the object inside are called elements or items. So if we consider a sequence, we can refer, if we want to, a sequence as a whole object, or if we want, we can consider individual element as well. So the object inside are called elements. And in a sequence, they are arranged sequentially. So there's an order. Okay. This unique index basically based on the position. Okay. So from left to right, the indexing start from 0. From right to left, indexing start from -1. Okay. So we can use the index operator to access an element in an index. Okay. And usually it is this operation is a single CPU instruction. So this access operation is a single CPU instruction. Okay. Depending on the sequence type, okay, elements can be same or different types. For example, if it's a list, you can have any type of elements. If it is a string, well, elements are also string type. There are also characters, right? Okay, so let's practice some of these a little bit. Okay, so I'm gonna first go to this Jamboard and let me write an example sequence as this word code. Okay, okay. So if I write this code in a table like this, okay, this word. So I'm going to simply write it in a table. Okay. C O D E. So indexing wise, positive indexing start from 0, 1, 2, and 3. Negative indexing start from right end. So -1, -2, -3, -4. Okay. So notice the length of the sequence is equals 4 here. So we have 4 characters over here. 1, 2, 3, 4. So positive indexing end 1 less than the length. Negative indexing basically ends at negative times the length. Okay. All right. So let's do some practice with simple sequences. Okay. So first my sequence is a list. This is a list. Okay. So let's say I want to access the first element, not the first element, the second element, which is the element, which is the index 1. Okay. So I'm going to print that. Okay. And I'm going to do the same for element number 2. Sorry, sequence 2 as well. And that's actually a string. Okay. So this is just to show you, okay, so you use the index operator to access individual elements of a sequence. Okay. And let's run it. Okay. So I got 2, this one, and I got O for the next one. Okay. So let's try the same for negative indexes. Okay. So I'm going to simply copy this right here. Okay. I'm gonna do a little bit like this. Okay. So I'm going to copy this right here. Okay. All right. So let's access -1 of both. Okay. And print it. Okay. So I got again 2. Okay. So, well, oh, sorry, I didn't change it over here. That's why. All right. Sorry about that. Okay. So let's run it again. Okay. So I got 4 over here. I have 4 over here. That's -1. And -1 of code is E. So I have E over here. All right. So let's go back to our lesson. All right. So ranges, Python ranges is one of fundamental sequence. Okay. So numeric ranges are really common, right? So for example, we can group and give them numbers. We can group things and peoples and things, right? And then give them numbers, okay? So integer numbers like group 1, group 2, group 3, like that. In counting, right? We can go one by one in counting. Keep counting. Sometimes we do like odd numbers, even numbers. We can do skip counting like that. So like odd even numbers. And seems like this kind of numeric ranges is a good thing to adopt in programming too, and that's what Python designers thought. Okay, adapting a numeric range into programming grammar would be useful, and it turns out you will see that it is really useful. Okay, so Python ranges basically mimic this idea of numeric ranges in reality. Okay, so ranges, it's a sequence, immutable sequence in numbers. Immutable means once you form, you cannot change it. Okay. So it's a built-in data type in Python. And we often use ranges in iterating using for loops. And then that's the reason that I am actually talking about ranges here. Okay. All right. So here's how we create a simple range. Okay, so we have the range built-in function and we pass the stop parameters, integer stop parameter into that. And that gonna give me of numbers from 0 to stop -1. So for example, range 5 would give me 0 to number 4. Okay. All right. So ranges are dynamic. So that means basically Python, once we create a range, Python not going to give out the entire range of numbers. It's only going to memorize, okay, so there's a contract to give out this set of numbers. So I'm going to just remember the function call, which is range, and the parameters pass into that. Okay. So basically values generated only when we demand them. Okay. So that's why if we try to print a range, we wouldn't see the numbers inside. Okay. So to see them, we can simply pass it to a list function, and then we can print the list. Okay. So that's what I have done over here. So let's check on that. Okay. So slide number 7. Okay. So I have this range. Okay. So I'm going to go full screen. Okay. So all right, so let's first, so I said this has to be integer, okay? So let's first check on that, okay? So I'm gonna run it like this. Oops, all right. So let's run, and I get an error, okay? So it's saying type error, float object cannot be interpreted as integer. So basically range expect integers, okay? So, okay, so that I'm gonna block this line. Okay, so let's continue with the rest of the command. So let me type this range and then see what we get. Okay, all right. So okay, so I get basically let's see, yeah. Okay, so when you run it, I get basically, okay, so right here, okay, slide 8, this one, okay. So let me see. Oh, okay. So let's practice on ranges. Okay. So I'm going to print this range right here. Okay. And let's quickly run it. Okay. So slide number 7. Okay. See, so it didn't print the numbers that I wanted. Okay. So to see it, so we need to basically pass the range into list. Okay. So we can do that. Okay. So I'm going to pass it and then print the list. Okay. So I'm going to, so let's run it. Okay. So I get this. Okay. All right. So these are the numbers that I created inside the range. Okay. So let's go back to our lesson. Okay. All right. So so moving on with ranges. So if we give a parameter that is not an integer, then we're gonna get a type error. So basically range accept only integer parameters. Okay. And we often use it in for loop. We already discussed that. And the most general form of range function, range call is basically we have the range function, we have the start, have the stop parameter, and we have the step parameter. Okay. So basically it returns numbers from start to maximum possible, basically less than step, maximum possible that is less than stop value, sorry, and in steps of step. Okay. So for example, if I pass 1, 6, and 2 like this, the start is 1, stop is 6, and the step value is 2, I get 1, 3, 5. Okay. So the defaults are basically start is 1, start default is 0, and the default step is 1. So if we provide 0 as step, we'll get a value error. So let's check all those things. Okay. So, all right. So I'm gonna uncomment this and run. So it's not an it's a floating point number, not an integer. So let's check on that. Okay. And I get this error. Okay. All right. And that's what I have written over here. Okay. All right. So we block this one to run the next. So I'm printing this range. Okay. So let me put it inside a list. Okay. So that I can see the numbers. Okay. All right. So I got this one. Okay. All right. And then if I put 0, okay, so I'm going to print that and you will see that it's a value error. Okay. So we put 0 over here and run it again. Okay. And it's a value error. Okay. So put it over here. All right. So I'm going to block that now. Okay. So let's go back to our lesson now. Okay. So ranges are, okay, basically the step parameter, positive step parameter. So there's an equation for calculating these range values. Okay. So here's the equation for the ith value. So it starts from basically start plus step times the I. So that's the formula. So I here has to be greater than or equals 0 and Ri has to be less than the stop value. Okay. So this is for positive step value. Okay, it's really important that you understand that. Okay, so for positive step value, here is the equation that we generate values, and these are the conditions. Okay, for negative step values, okay, it's going to be the same equation, but notice the ith value has to be greater than stop. Okay, so any ith value has to be greater than the stop value. That means start has to be greater than stop value. Okay, right? So, so for example, basically for R0, okay, so if this value constraint is not met, basically we would get empty range. Okay, so R for positive step R0, the first value of the range has to be less than stop. Okay, and that is the case, we're going to get non-empty range. So for negative step value, R0 has to be greater than the stop value. So that's when we get non-empty range. Otherwise, we're going to get an empty range. Okay. All right. So, all right. So that's about ranges. So this is not a comprehensive lesson on ranges. We just simply went over just enough we need to go over for loops.